LeetCode problem 11. Container. With most water, isn't just a geometry riddle. It shows up in real-world optimization, from memory layout to cloud scaling. Imagine picking the right two servers to maximize usage without overload. Same idea. It looks simple, but brute force will sink you fast. The trick is doing less while still finding the best result. All right, ducklings, time to paddle into brute force. We'll try every pair of lines and see which combo makes the biggest splash. Let's drop in a variable to track the max area we've seen so far, and keep updating it anytime we find a better container. We'll anchor the first loop to pick the left edge of the container, trying every index as our starting wall. For each left line, we scan forward to try every possible right edge that follows it, covering all pairs. With two lines at I and j, the area is the distance between them times the shorter of the two heights. That's our container size. Once we've got that area, we check. Is it better than our current max? If yes, we upgrade. After trying every combo, we return the best area we found, and that's our brute force solution. But here's the problem. This brute force method runs in big O of n squared, which means billions of checks on large inputs. Not duck-friendly at scale. It only uses constant space, but the runtime? Brutal. Accurate, yes, but painfully inefficient. So how can we do better? Let's ditch the nested loops and try a two-pointer strategy, scanning smartly from both ends. First, we'll need a variable to track the best area we've seen, so we'll start that at 0. Then we set 2 pointers, one at the start, one at the end, so we can compare the widest containers first. We'll loop while the pointers haven't crossed, shrinking the window one step at a time and checking what we can trap. At each step, we grab the width between the pointers and the shorter height, since water can't rise above that. Multiply width by the shorter height, and we've got our area. If it beats our max so far, we update it. To chase a better container, we move the pointer that's shorter, since only a taller line can boost our next area. Once the pointers meet, we're done, and the max area we found is the best container possible. This two-pointer trick cuts runtime to big O of n, just one pass. That's 100,000 lines, 100,000 steps, duck efficient, still constant space too. It's elegant, scalable, and a go-to move in interviews and real-world systems alike. We started with brute force, solid but slow, at big O of n squared. It checks everything, but drags badly at scale. Then came the two-pointer technique. Not just faster, it flips the problem on its head. Instead of trying all pairs, we work from the outside in, narrowing smartly. One pass, constant space, clean and powerful. This strategy shines in caching, UI layout, and more. It's an interview classic for good reason. It shows you how to skip wasted work and think with purpose. So try applying this trick elsewhere, and keep sharpening that algorithmic beak.